Alright, Assalamualaikum. Okay, so now we are proceeding to paper 3 times zone 2 question 2. Okay, right, so this is a differential equation question. Okay, so rather wordy, so let's read first. Okay, so Alicia is an ecologist. Okay, so the one in bold kan. Okay, jangan tak baca please baca So Alicia is an ecologist working for Mediterranean fishing authorities. She's interested in whether the mackerel population density is likely to fall below 5,000 mackerel per kilometer cube. Okay, as this is the minimum value required for sustainable fishing. Okay, she believes that the primary factor affecting the mackerel population is the interaction of mackerel with sharks, their main predator. Okay, so first question, they start off by saying that the population density of mackerel m thousands per kilometer square cube and sharks s per kilometer cube. Okay, in the Mediterranean Sea are modeled by the couple differential equations. So let's write it down. So we have dm dt is alpha m minus beta ms, and then ds dt is gamma ms minus delta s. Okay, where t is measured in years and alpha, beta, gamma and delta are parameters, okay, fixed values kind of thing. Okay, this model assumes that no other factors affect the mackerel or shark population densities. Okay, the term alpha m, this one, okay, models the population. Alpha m models the population growth rate of the mackerel in the absence of shark. Okay, so kalau shark tak ada, pasal awak tengok kat sini ada S, so that means ada shark. Okay, so kalau shark tak ada, just this alone, okay, this will represent the growth rate of the mackerel. Because ni mackerel lah, so dmdt is how fast does the mackerel grow. Okay, the population grow lah. Okay, so alpha m models the population growth rate of the mackerel in the absence of shark. Okay, and beta plus m and s ni, okay, beta ms models the death rate, okay, of the mackerel due to being eaten by sharks. Okay, so let's try to break it down first before we answer the bawah. Okay, so what it's trying to say is, kalau this one, right, okay, is when this thing tak ada, okay, is how fast does it grow. Okay, so you put the number, let's say the number is 1,000 sini, okay, then probably kat sini is like 1.5. That means is growing at the rate of 1.5. Nanti lepas tu ada 500 lagi and all that. Itu maknanya kat sini. Okay, so yang kat sini, kenapa is considered the death rate? Okay, satu awak tengok dia punya, kalau you compare ni alpha m, yang ni beta m, tapi dia tambah s. That means the number of sharks will have an effect on it. Okay, so dia bukan just macam gini je. Dia ada s yang you multiply tu. So kalau ada 3 shark, you multiply by 3. Okay, kalau dia ada 2 shark, you multiply by 2. Dia ada extra ni. Okay, so the thing is, lagi satu yang orang kena tengok is this minus sign. Okay, so when you have something that is growing, okay, and then you minus another thing, that means this one overall dia akan jadi total overall punya growth rate. Okay, or total population change. I don't say growth lah, maybe dia turun, maybe dia naik. Okay, so what happens is the growth minus the death, okay, will be the total overall change in the population of the mackerel. Okay, so this is growth, this is death. Okay, okay, so now dia dah kasih that clue. So now you try to answer. Suggest similar interpretation for the following terms. So this one first. Okay, so as you can see, dia mackerel dengan shark together. Okay, so how do you want to link it? Okay, awak tengok kat sini kan sama. Dia ni, lepas tu minus, lepas tu ni. Okay, so let's say if this is growth rate, if let's say you want to say that this is growth rate, does it make sense? Okay, so the more mackerel you have, okay, the faster the growth rate is. Pasal awak kalau times 3 benda ni jadi besar, awak times 4 lagi besar, times 5 lagi besar. Of course 4 3, 4, and 5 is like thousands. Okay, so it makes sense for you to say that this component, the first part, is the growth rate of the sharks, okay, as the mackerel increases or something like that, okay, or based on the mackerel size, okay, mackerel population size. Okay, so dalam artikel dia taruh population growth rate, birth rate pun boleh, due to eating mackerel. Okay, the due to eating mackerel is if you have to put equal lah, tapi kalau basically the growth rate. Okay, alright, then you see the minus again. So kalau ni growth, ni minus, mesti this one should be the death rate of the sharks. Okay, so the death rate is only dependent on the shark itself. Okay, that means berapa shark kat situ, ni lah jumlah dead number of shark, nanti ada berapa yang akan mati. Maybe half of them will die or 1/4 of them will die. Okay, so this is 1/4, that means how many number of sharks there are, you times by 1/4, that is the number of sharks that will die. Okay, so this question, dia nak awak tengok the clue yang dia kasi, link it to this one. Okay. Alright, an equilibrium point is a set of values of m and s such that dmdt equals to 0 and dsdt equals to 0. Okay, given that both species are present at the equilibrium point, show that at the equilibrium point, the value of the mackerel population density is delta over gamma. So, let's see, dia nak mackerel population Okay, so kat sini okay, dia cakap delta over gamma kan. So that means delta over gamma appears here. Okay, so that means you know that what you're supposed to do is set this to be 0. Okay, so we let ds dt equals to 0. So then gamma ms minus delta s is equals to 0. The s can be taken out. Delta m minus gamma m minus delta equals to 0. Okay, but you see, dia ada cakap yang apa? Both species are present at the equilibrium point. That means s is the number of sharks. So s is not 0. Okay, since s is positive, ada kat situ. Okay, so therefore delta m minus gamma m minus delta, okay, is equal to 0. Okay, so you solve this, you get bring over delta over gamma. Okay, this one very important. Okay, because kalau you tak cakap benda ni, okay, then this may not be true, tapi s yang 0. Okay, pasal tak ada shark. Okay, so for this question, they look for the part where you say the shark is positive. Okay, or you can say shark is not equal to 0. Okay, alright, what else? Okay, find the value of the shark population density at the equilibrium point. So now we are looking for the shark one. Okay, so shark one, I think I will use this first. Okay, for the shark one, we know that kalau kita tahu tadi kita pakai ni, nanti kita dapat M. Okay, we try to do the other one. Okay, that means now dmdt is equal to 0. Okay, so kalau kita factorize, kita taruh M bracket alpha minus beta s is equal to 0. So m is positive. Okay, so therefore you solve this, you get s is equal to kalau tak silap is alpha over negative alpha over beta. Let me see that. Alpha minus beta. It's just alpha over beta. Tak payah lagi. Then you bring over. Okay. Alright, so then let's look at the next one. The equilibrium point found in part B gives the average values of m and s over time. Okay, use the model to predict how the following events will affect the average value of m. Justify your answers. Okay, this one I'll just verbally say. Okay, so far we have this dengan ini. Okay, how it changes. Okay, over time. Okay, first question is toxic sewage is added to the Mediterranean Sea Alicia claims this reduces the shark population growth rate and hence the gamma is half. Okay, no other parameter change. So if gamma is half, okay, so what you do is you have to find the equilibrium. Okay, is delta over half gamma. So that means it's equals to 2 times. 2 times of the m. Okay, and yeah, okay, it will be twice. Okay, so that means what will happen is dia tanya how it will affect the average value of m. So okay, the value of m will double. Okay, the value of the number of mackerel will double. Okay. Next one, global warming increases the temperature of the Mediterranean Sea. Okay. Alicia claims that this promotes the mackerel population growth rate and hence the value of alpha is double. Okay. Okay, so value of alpha is double. Okay, kau pernah tengok bila dia cakap yang tadi tu kan dia cakap the shark population growth rate. This is the shark population growth rate. Okay, so that means the gamma is the population growth rate. That's why ni lah. Okay, bila dia cakap yang pasal the global warming, okay, population mackerel naik, so this is the mackerel growth rate. Okay, so therefore the growth rate is only the alpha. So dia cakap alpha akan berubah. Okay, so alpha will be double. So kita nak tengok M tau. Kita tak nak tengok ni. Kita tak tanya pasal shark, kita tanya pasal mackerel. So kalau alpha changes, this one got no effect. Okay, so therefore no change for the mackerel size. So global warming doesn't neither increase the size of the mackerel, but if you put toxic sewage, it will double the mackerel population. Okay, probably the toxic sewage will actually cause the shark to become lesser, so that's why mackerel dia makin lebih. Okay, alright, put it into context based on your values and awareness. Alright, next one, part B. Let me erase first. I think I can simply erase some more except that. Okay, I just erase one, okay? Okay, next one. To estimate the value of alpha, Alicia considers a situation where there are no sharks and the initial population density is m0. Okay, write down the differential equation for m that models this situation. Okay, so if you see your original equation, let me write it down again. Okay, your original equation is dm dt. Okay, it's just alpha m minus beta ms. Okay, for this context pula, dia cakap kita nak try solve alpha lah. Okay, this is our original equation. Dia cakap we consider is a situation where there are no sharks. No sharks means s jadi 0. So if s jadi 0, this whole thing hilang. So this part disappears. Okay, take note of that. Okay, next one dia cakap write down the differential equation for m that models this situation. So this is number 1. Okay, because the net s dia hilang. Okay, part 2 is part 1. Part 2 lah, dia cakap show that the expression for the mackerel population density after t years is m equals to m naught e to the power of alpha t. Okay, so ni sebenarnya dia nak test kita punya differential equation punya solving. Okay, so basically we start off with this thing. Okay, and then we pasal m kat sini kan, atas ni, so m ni kena bawa turun. So 1 over m dm is equal to alpha dt. Okay, once it's done with this, baru kita boleh integrate both sides. Okay, you do this, dia dapat m1. Okay, kan cikgu dia cakap, every time kalau yang awak nak buat differential equation, it's always ni kena bawa sana, then that's it, you solve. Okay, so solving this, you have ln m is equals to alpha t plus c. Okay, then you solve for ni, what's completed, you get e to the power of that. K e to the power 1 alpha t. Okay, so how did they get the K? They will get